So we're going to look at solving absolute value equations. And in this video, I'm going to stick with equations based on linear equations, so x will have a power of 1. But the general idea here can be applied to other types of equations. So just a real quick reminder, when we talk about the absolute value of a number, this is the distance this number is from 0. This is also called the magnitude sometimes of the number, the size of the number. So, -3 and +3 both have an absolute value of 3 because their size is size 3. It's just whether you're going up or down, left or right, whatever positive and negative are supposed to denote in those cases. So we'll start with kind of a simple equation here. Let's say I have the absolute value of a number is 8. Well, I know then that this number in here has to be an 8, because the absolute value of 8 is 8, or this number has to be -8, because the absolute value of -8 is also 8. So I'm getting two possible answers here. Let's make this a little bit more complicated. Let's say I have x minus 3 equals 8. Well, without trying to initially figure out what x is, I know whatever's inside this absolute value, this thing, from this previous example, whatever's in there either has to be an 8 or a -8, whatever this is. So it's got to work out to be 8, or it's got to work out to be -8 in order for this absolute value to be 8. Well, if x minus 3 equals 8, then if I solve that, add 3 to both sides of the equation, then x equals 11. If instead this comes out to be -8, then if I add 3 to both sides of the equation, I get -5. And you can see, if I do -5 and a -3, that gives me a total of -8. Absolute value of that is 8. And if I have 11 minus 3, that's 8. Absolute value of that is also 8. So those are my two real solutions to this problem. And then we can just, increase the complexity of this equation, but that's basically the idea here, is you're going to be setting up two problems. So if I say, let's solve absolute value of 3x minus 4 is equal to 20, then I would say, well, 3x minus 4, whatever's in here, is either a 20 or 3x minus 4, whatever's in here has to work out to be -20. So if this is a 20, I'm going to add 4 to both sides. So 3x equals 24, divided by 3, x equals 8. So that's one possible answer. Or if I add 4 to both sides here, what's that, -16, divided by 3. So another possible answer is -16/3. And both of those are possible answers to this problem. Now, let's say I wanted to solve something like the following. Let's say I have 2 minus 5 absolute value of 4x plus 6 equals -8. I cannot say, I might be tempted to say something like this. 2 -5 times 4x plus 6 equals -8, and 2 minus 5 times 4x plus 6 equals +8. That might be a temptation. And what I would find out is if I worked out these two problems, this one would not actually give me a correct answer. So that's not going to work. So I got to think about another way to approach this. So probably the easiest way to approach this is not to do this yet, not to try to set up these two problems yet. Instead, on these other examples here, notice I had the absolute value equals number, absolute value equals number, absolute value equals number. So what I want to do is I want to get this one so that I isolate the absolute value first. I want to get rid of this 2 and this -5 before I start worrying about setting up the two problems. So notice this is not -3, it's 2 minus 5 times this. So, you know, order of operations would say you'd multiply by 5 before you would subtract. Since I can't actually do the multiplication, I can't ever get to the subtraction. But that's okay because I want to solve it. So I want to get rid of this 2 first. Remember, it's kind of like doing the order of operations in reverse. You start with the adding and subtracting things, separate terms first. -8, -2 make -10. And then I want to get rid of this multiplier of -5. Remember that sign is with the 5, so divide both sides by -5. And I get the absolute value of 4x plus 6 equals 2. Now that is what I'm going to write my two equations of. So 4x plus 6, whatever's in here, has to be 2, or whatever's in here has to be -2. And before I go on, I just, let me real quick jump back to these other examples. Notice when I set up my two problems on this x minus 3, absolute value of x minus 3 equals 8, my second one, I didn't change the sign of x minus 3. I just said whatever is in there, which is x minus 3, that's a -8. So I'm not trying to do the absolute value and make everything inside here become a positive number. I'm just saying that whole thing as a unit, it's a single item, is either an 8 or a -8. Same thing on this second example. 3x minus 4. Again, I didn't try to change any signs here. I just said 3x minus 4. That whole thing is either 20 or that 3x minus 4 equals -20. So, in this case, it may not really matter. 4x plus 6, you may not be tempted to do any sign changes. But in those other ones, you should not do sign changes of the things inside if you're using the method we're talking about here. There may be other methods to do this type of problem. And I might mention those near the end of this video, but right now that's not how I'm doing it. Okay, so I went ahead and solved this, subtract 6 from both sides. 4x equals -4, divide by 4. X could be -1, subtract 6. So 4x could equal -8, divide by 4. X could be -2. And again, it doesn't matter what the signs of these numbers are, it matters what happens when you plug them in. And so if we plug those numbers in, if you wanted to check those, let's say, do that in a different color, I'll say red. So 2 minus 5, I'm just going to check the -1. So this would be -1 times 4 is -4 plus 6. Does that equal -8? And so order of operations say you do this group first. So 2 minus 5, -4 plus 6 is 2 equals -8. Then you would do this operation here. Absolute value of 2 is 2. And then multiply -5 times 2, that is -10. And then 2 minus 10 is -8. Yes, it checks. So that's how you can check those answers, see if they work. And -2 would work also. It just, what would happen is we would get, you put a -2 in here, this would become a -8. So this would be a -2. Absolute value of -2 is +2. Same answer. So both of them work. That's how you could check those answers. But as soon as I saw this, I knew that I was good. So let me mention, what if that's that situation? Well, let's say I asked you to solve this problem. Absolute value of 4x minus 1 equals -6. Without doing any work at all, I could just say no solution. Not going to work. And the reason why is you cannot take the absolute value of something and get a negative. Absolute value is always the size of the number, but no negative sign. So, the smallest it can be is 0. Can't ever be a negative number. You might look at this previous example. Notice I had a -8 here, but that's because the absolute value wasn't by itself. Once I got the absolute value by itself, I could make that determination. Say, oh, +2, yeah, that could equal +2. So I could work those out and see that it works quite well. But this one, there's no way an absolute value can equal a negative unless there was a negative out front. And so again, the first thing you'd want to do is change, multiply both sides by a -1, for example, and change that to a positive, and then it would be solvable. Now let's go to a slightly more advanced problem. Let's say I wanted to solve the absolute value of 2x plus 3 equals 4 minus x. So I want to solve that. Does it have an answer or not? Well, what the heck is that? All right. Does it have an answer? Maybe. It depends on what x is. You can think if x is like 1, then this would be 4 minus 1, which would be 3, and that would work. On the other hand, if x is 20, this would be 4 minus 20 would be negative 16, and it wouldn't work. So going into this problem, I don't know if it's going to work or not. It depends on what the value of x is. And you've been noticing we've been getting usually 2 answers. It could be that I could get 2 answers here, but one would work and one wouldn't work, or both would work, or neither one would work. So what I'm going to do is I'm going to start off acting like it could work. So first thing I want to do is make sure my absolute value is by itself. Yep, everybody's on the other side. So now I want to solve this. 2x plus 3 equals 4 minus x. 2x plus 3 equals, and if you remember, when I set up these 2 problems, I did, 2 was out here, and I said 2 and negative 2. 20 was out here, I said 20 and negative 20. 8 was out here, I said 8 and negative 8. Well, what I'm going to do here is I'm going to do one of these is going to be 4 minus x, and the other one's going to be negative 4 plus x. That's the opposite of 4 minus x. Negative 1 times 4 minus x. You distribute the negative 1. This is what the opposite function would look like. So now I'm going to solve both of these independently. I'm going to subtract 3 here, and maybe I'll go ahead and add x. So I get my x's on one side, my non-x's on the other side, so I get 3x equals 1, divide by 3, x equals 1/3, maybe that's an answer, maybe not. Same thing here, I want to get my x's on one side, so I'm going to subtract x. 3 doesn't have an x, let's move that over. So x equals negative 7, and I got negative 7 as a maybe answer. Now, again, it doesn't matter what the sign of this number is, it depends on what it does in the problem. So what I really am concerned about is whether this part right here comes out to be a positive or a negative. If it comes out to be a negative, that's no solution, just like this problem. If it comes out to be a positive, then that will work. This part will work out as long as I've done all the algebra correctly. It's going to work. So really all I need to do is check this outside part. So if I do 1/3, 4 minus 1/3 is 3 2/3. That's okay. That's fine. That works as an answer. What about negative 7? Well, 4 minus negative 7 is the same as 4 plus 7. So that's 11. That works. So both of these work as answers. Sometimes in a problem like this, you might get, no answer. You might get one answer. Or you might get both answers, like in this case. So that's solving linear equations, or absolute values based on linear equations.